Air pressure is the weight of air above and around us.
It is important to measure air pressure on Mount Washington, just like at other weather stations, because data about air pressure helps us predict future weather. On Mount Washington, we use digital sensors to measure the air pressure. We also use mercury-filled and graphing chart barometers that record pressure over time. It is not common to see mercury barometers these days, but we continue to use them to maintain a consistent approach to our measurements.
So shown here is a bag of chips, which is one item that actually inflates as it comes up with us up the auto road. So we actually change pressure from the base of the auto road to when we get to the summit. We have 20% less atmosphere above our heads, and so we actually start to see some things like this expand with the less pressure up here on the mountain. We measure air pressure to know about what systems are coming, whether it will be a high or a low system. Low pressure systems typically associated with poorer conditions, things like stormy weather, and for us, maybe higher winds, as opposed to high pressure systems, which are typically associated with things like clear skies and nice days. Air pressure is typically measured by a barometer, and we do have a set of barometers up here on the summit. We do have a mercury barometer and a barograph, which is going to show the trends of pressure systems. Our mercury barometer measures air pressure by the movement of inches of mercury, where the higher the inches of mercury are, the higher the air pressure as well, and vice versa. So the units of air pressure are inches of mercury and also millibars. Millibars being the one that's commonly used by meteorologists, and inches of mercury being well known by the public. During windy events on the summit of Mount Washington, we typically will see pressure fluctuating depending on gusts. So if it is very gusty, you can also see pressure jumping from high to low depending on where you are within that gust, either whether you're in a lull or the high wind peak. During a microburst, that would be a very strong thunderstorm that has a pocket of precipitation and air that falls rapidly out of the thunderstorm, and that would cause a sudden and sharp increase in the wind speeds, and also a sudden and sharp difference in pressure, whether that be rising rapidly or falling rapidly.